and did not buy into the politics of any of this. And just like that, I mean, he saw this several times, and then he said, this is a demolition, because he actually had a name. I can't even remember the name he had for this. But it's a known type of thing that happens in these explosive demolitions. Now, I am very active in this process, and I actually came up with an observation that I actually finished documenting at 12:30 last night. So this is a new piece of material coming up here. There's a 9/11 researcher named Graham McQueen, who's from Canada, and he's done some very interesting stuff. But we've been corresponding. And he went down through this and pointed out this little puff right here. Everybody see that little puff? Anything unusual about that little puff? There are some next to it.
There are different colors.
It's a little different color, but what else? Well, you can't tell that from a freeze frame, but it turns out that's a true statement. But the thing that's interesting, if you notice, is let's say that these are puffs of air that are blowing out due to compressed air like the official story would indicate, right? They would be pushing out through the windows and things, right? Where's this puff coming from? It's blowing right through the corner of the building. And in fact, he got this zoomed in, and I don't know if I can actually zoom it in just like he did or not, right there.
Oh, yeah.
Right, that frame right there. See this? He actually saw it as it's pushing the material off the corner of this building. All right? So this is coming through a steel girder. So he was saying this puff is not a puff of air. This is what they call a cutter charge. In other words, an explosion strapped on to the girder, or in this case the column, to get it to slice the column. And so he pointed that out a week or so ago. And I started looking at that, and I started looking for other similar things. So keep that in mind. We'll come back to that in a minute. All right? Tons of stuff. By the way, one other little factoid here. See these neighboring buildings? There's actually one on the far side that you can't see from here. The bone fragments, millimeter-size bone fragments, were found on the roofs of neighboring buildings. Now think that one through. If you were trapped in this building and it collapsed, what would be your mode of death most likely? You'd be smashed between the collapsing floors, right? Where would you look for your remains? How about in the rubble pile at the bottom, right? In order for bone fragments to get on the roofs of adjacent buildings, your bones, you would have to be pulverized down to that scale and still be out in the open enough to be blown out by what's going on here, to be ejected and to have these fragments found nearby like that. Like, how do you have a mechanism that would just involve collapse that could allow these bone fragments to even get there? Okay? And that was a big question. These were found several years after 2001.
What about also, there was also a victim in there that they counted 2,000 pieces for one person?
What about the people on the plane? Couldn't they be blown out?
I actually, some people looked into that. I looked into that myself, and if you look at the flight paths, there's no reasonable way. In other words, the North Tower, the plane that hit the North Tower came in from the north, and it would not have been in line in any way with this building where the bone fragments were found. The plane that came in hit the South Tower, flew over that building before it hit the South Tower. So it was moving away from that building. So neither flight had an obvious mechanism where this could have been like fragments of the passengers, for instance. Okay. Okay. All right. I mentioned a moment ago that that one particular row of ejections that was low in the building there. All right. This is from a different angle, and the reason I'm showing this is it's going to show that that same group of ejections. Here's the north tower starting to collapse. This is the same wall we were looking at a moment ago. And look under here. Can you see that stuff is moving to the right? You see that? So it's not just material coming down. It's a wave of material right there. You can just see it blowing left to right, can't you? Did everybody see that? And notice that the wave is progressing. If you follow this, this is large chunks of material here. And it's not exactly the same speed, but it's pretty darn close, right? So it's a wave of explosions that is propagating down the building faster than any mechanism I can imagine other than a timed sequence of explosions. Okay? And I have one more, I'll just skip over it, but it's all the same general idea. Okay. Okay, this one is, all right, let me pause this a second. This video is, I don't know why it's doing that. This video is slightly more technical than some of the others that I've actually put on YouTube. However, among those who are like into physics and that type of thing, they point to this one as the most persuasive. So some people are more persuaded by this one. It's a very simple kind of reasoning, but it does imply knowing a little bit of physics. So here goes. This is the start of the collapse of World Trade Center number 1, also known as the North Tower. We are here tracking the motion of the roofline at 0.2 second intervals through approximately 32 meters, or 8 stories. This graph shows the height of the roofline as a function of time. The analysis is simpler if we plot velocity as a function of time. On this kind of a graph, a straight line indicates constant acceleration. First note that there is a sudden onset of collapse, as the point we are tracking makes a sudden transition from being at rest to an approximately constant downward acceleration. The slope of the graph indicates that the acceleration is 6.31 meters per second squared downward, which is 64% of free fall. In other words, once it starts falling, the upward resistive force is only 36% of the weight of the falling section of the building. So far, so good. But now turn it around. Newton's third law says interactions between objects work both ways. The forces two objects exert on each other are always equal and opposite. If the upward force acting on the falling block is 36% of the weight of the falling block, the downward force exerted by the falling block must be exactly the same, 36% of the weight of the falling block. In other words, the top section of the building is exerting less force on the lower, stronger, undamaged structure than it would if it were simply sitting